Let me kind of give you a rundown of what I'm kind of the goal here is. Real quick, I'm Tony Champion. I've been a .NET developer for 25 plus years now. I was an MVP for about 8 years. I've been speaking all over the place and just kind of ramping back up on some of the speaking and such. But what I want to come here today is talk about APIs, specifically as it relates to Azure and .NET, and kind of give you some real world problems, examples, and things like that that we've come into off of my current project.
Hey Tony, could you unmute? They can't hear the room very well, but they can hear you. So if you unmute your laptop.
All right, how about now? We doing better now, hopefully?
Yeah, let's go with that.
Cool.
As you were.
All right, cool. So to talk about where a lot of this material came from, and I work for a company called Quidel. Well, I'm a contractor through a company called Quidel, and we started. You've actually probably seen the name and not realize it. They are one of the companies that do rapid testing. Prior to the pandemic, they did rapid testing for flu and RSV. And so most of their machines are in doctors' offices and clinics and things like that. They have in the process of this done take-home tests. So you'll probably, if you've had take-home tests, more than likely they're one of the top 2 or 3 that depend on which region and stuff you're in. We happened to, it was in 2019, they had a system called MyVarina. And all this test data that comes in, it gets done, it gets routed back to the main Quidel servers, and which are in Azure in this case, to get processed and displayed and things like that. They had a .NET solution that was just miserably slow. And by miserably slow, I mean you would log into the system and it would literally take a minute and a half for the opening dashboard to load up. And what they wanted us to do was to go through and basically rewrite it from scratch. The guy that was in charge of the project, still in charge of the project, was a huge Azure guy, wants the latest and greatest of everything, which makes it a lot of fun for developers, especially in Greenfield, because anything that you wanted to do, he was all for it. And a lot of times he was throwing stuff at us that were like, can't you stop? We've got enough. We don't need to add everything else. So, long story short, we rewrote the solution, went through a lot of things I want to talk about here. And this project launched literally in February 2020. And we had a 10-year goal. At the time, the program before us had been running for about 10 or 12 years. And there was about, if I remember correctly, 4.5 million test results in the system. And they had a good growth curve going. And so we had a 10-year goal that in 10 years that we should be able to ingest 1 million records in a year and the system still perform. And at the 10-year mark, when they hit that, they would look at rewriting and revamping anything that needed to be done. It was February 2020. Fast forward to that summer, and we're cranking through 1 million records a month or a week. And all of a sudden, all of these painstaking things that we did and trial and error things that we did and all that worked because a system that they were expecting in 10 years to have maybe 15 million records in currently has almost 100 million in it. And it's still cranking on the rate of, we get about 100,000 to 200,000 records a week being pumped into this thing now. So that's kind of just give you a layout of where this came from and kind of where some of this stuff kind of its genesis. Now, what we did is we were really heavy on Azure and all of the pieces. And one of the things that when I've talked to other developers and such, a lot of times you'll see is there's always really good use cases of, well, this is how you use this one thing. This is how you use this one thing. This is how you use this one thing. Or on the other side of it, here is this massive enterprise level architecture that's got 1,800 moving parts in it, and good luck trying to reverse engineering and figure it out. So the goal of this talk is let's walk through some of the problems that we had and some of the challenges that we overcame and some of the things that worked for us and some of the things that didn't work for us. So that when it comes to you looking at building APIs, scaling APIs, and looking at your system, hopefully some of these things will make sense and some of you can use some of these nuggets or maybe inspire you. That's really these talks. I mean, I've got a little over an hour, less since I'm a little late, but to kind of walk through and kind of just give you some insights to hopefully help some of your projects, whether they're current projects or future projects. I love these to be very informal, especially given the fact that I'm kind of walking through the thought process we had and the things we did and the things that worked. So please, if you have questions, just let me know as we go through. And I guess if there's questions online, just let me know.
Yeah.
Perfect.
Yeah.
And then we'll hash those out. Does that work for everybody? Excellent. All right. So the first thing I want to talk about is front door. So this is an Azure group. I'm just going to make an assumption. Anything that I throw out there Azure related, you ought to at least know about. So I'm not going to kind of do this is what a front door is and walk through it. But if there's anything I talk about that you haven't heard and you want to know a little bit more about, just say, hey, what is that? And I'll go into that. Otherwise, I'm just going to assume that you have at least base level knowledge of it. Does that work? All right, so front door. One of the first things that we decided to do was to use front door. We did it for a couple of reasons. One was just obfuscate where the Azure websites were. It worked. We could put the domain names on there. We could have a little bit more control of that. But one of the things that we did was for one of our projects supporting this is we needed to, I guess, fast forward about a year, we're about 2021, we needed the ability to go through and ingest a ton of data. Because what we ended up doing was they partnered with, for the take-home test, there is an app with it that scans and all. That's a third-party solution that they bought. And the only way this third-party solution would work is if they could send us data one test at a time in a rapid batch of everything they've collected the data for. So we had to have a system that could handle from this server and about 5 different servers spread across the US that would be split across depending on where you used it. And we had the requirements of, hey, you need to be able to ingest up to 250,000 records in an hour. So the problem, and if you've gone through, real quick, and if you've gone through and, see, I'm not sharing, hold on, let me see if we can fix that sharing part. Spotlights, share, got it, here we go.
Yeah.
We're just gonna share our entire screen. Yeah. That screen there, all right. So perfect. All right.
Yes, that works.
Perfect. All right. So what we are going, resolution looks like it's all right. All right. Okay, if anybody knows anybody in the Azure team, I don't know why they can't save this display, this group by type, why they can't make that by default. Because every single time I load the screen, I switch that, and I've yet to get that to. So if anybody's got it in, can you tell them to at least remember your settings on that? Awesome.
Good feedback.
All right. So what we did was we had to have this massive amount of data coming through. Now, the problem we had, Azure APIs are fast, right? You can scale them up, you can add bigger machines and add more memory and all that kind of good such. But the thing that I'm going to continue to talk about this entire talk, that a lot of developers that I've met that kind of trip up on, especially if they're not full stack developers, is it's typically not the API that's the actual API front end that's the block. It's all the resources on the back end that is the bottleneck, and it causes you problems. And we'll talk about Cosmos a little bit later, but we use Cosmos in a lot of these solutions for our back-end data. And Cosmos is great for that and great for storage of that, but Cosmos is very finicky and it really has its rate limits that it sticks to. And so if you're running an API where you're trying to write a lot of data to Cosmos, it does not take long before you start getting 429s stacking up and you start having errors and having to deal with that. So a lot of these things we had to be careful and cautious with Cosmos, right? Especially when you're looking at Verena that has Cosmos as a backend. You can't have your ingestion of all this data blow up your rate limits and people trying to query and try to pull data from it can't get to it, or some of our backend services. So it's all about kind of architecting things the correct way to make it kind of all flow well. And so what we ended up having to do, though, for this particular case was we could not find a scenario in which we could ingest that many records in an hour and actually save it in Cosmos. It didn't matter how hard we tried. We did everything under the sun we could. It was just simply too much data coming in an hour to not periodically still run into 429s. And then with a lot of the backend data systems that are going on cause problems. So what we did was we created our Azure front door. And on our Azure front door, basically what we ended up doing was, this is kind of before Bicep, so we have PowerShell scripts, but we created regions for our processing. Used Azure front door to bring everything in, and we broke it up into multiple regions. Like right now, we've scaled everything back. We're only running 3 regions in prod right now, but we were at one point running 5. What front door allowed us to do was to not scale at okay, we have our app service running in Azure and we just want to scale up instances on that one particular instance. This allowed us to geographically locate and spread apart the data processing. It worked great. It gets tricky after that because we have a Cosmos in each instance of our regions. Just so where the only thing happening to that, there's no back-end processing or anything like that, is we basically taking data and shoving it in there as fast as humanly possible. And we got it to where running 5 regions, we were actually running almost 1 million records an hour, is what we were actually be able to process and be able to dump these things. We load tested it and was able to do that. So the first thing we did with front door was to do this. Now, the interesting thing about front door, and the thing that works great, is that with these backend APIs, especially if you enable health checks, is that front door will take things offline and will route to the other regions if you have something go down. So back in the case that you have an app service that you just say, I want to run more instances, it's still running in that region. That region goes down for some reason. You're out of luck. I don't care if you have 20 instances running in a region. If you can't get to the region, you can't get to the region. So this allowed us to handle that and to deal with outages. And we ran into it a few times. One of the cool things that we ended up doing that this kind of prompted and allowed us to do is that as we had updates and had rollouts, instead of bringing the entire system offline, we could update one region at a time. Now, we ended up doing that. Let's see if I have it. We ended up doing that with using app configuration. Everyone know app configuration?
No, I have no idea. What's that, Tony?
You have not used app configuration?
No, not a clue.
So app configuration is Azure's nice little utility. It has 2 main features in it. One, it gives you a central place to store regional settings. Do we have one here so I can talk about it?
Yeah, demos are always good.
Let's look, we have all kinds of configurations in here. All right, so we have 2 big parts that we use it for. One is our configuration explorer. Very similar to Key Vault. It basically allows you to...
Could you hide on that little window at the bottom there, Tony? There we go.
One of the things that allows you to do is to basically create settings that you can share across instances, whoever has access to it. So you can have multiple APIs, multiple functions, whatever the case is. Read the configuration settings from app configuration, and you can share those among groups. The other, okay, we're going to switch groups. So what we use app configuration for, while I'm talking this through, is see, back to group by type. We ended up using our feature manager, which is a great little tool for APIs, and if you don't use it, you should. And this allows you to basically create a bunch of Boolean flags for features. And it's an amazing way of turning features on and off your applications, your APIs, your functions, whatever the case is. We ended up using the app configuration for several things along those lines. But one of the things that we implemented was the ability to turn off or make certain APIs unhealthy. So we created an endpoint in here, a feature flag in here, and we let's see if we show you guys in here.
It's about 0 10.
All right. So what we ended up doing was creating feature flags so we could turn off a given instance and basically make it unhealthy. And so once front door saw that it was unhealthy, it no longer routed traffic to it. Give it a minute or two to all the current traffic coming through to get rotated out, and then we could take it offline and we could upgrade it and bring it back online one at a time. This is very important for some of our sources that we did this to, because we literally had data coming in 24 hours a day, and it was too big of an audience to take anything offline. So that works great to be able to do. And let's see, GitHub here. Let me come down to my current repository. Let's grab that. Azure demos. All right. So the other really cool thing about feature flags, I'll show you, is that you can create labels for your feature flags. So like here we've got our file signature verification. We have two of the same things. One's client and one's instrument hub. So you can, and we use this same kind of concept whenever we were basically using our different regions. Each region would have a different label it would look at. So you could have code for it once, use the same code across all your APIs, and then they could all connect to the same app configuration. The ones that had no labels are shared. That wouldn't need to go across all of them. You could do that, or you could create specific region-specific settings. One of them being, is the application unhealthy? So that way we could toggle that on and off. So this is a great little way of extending app configuration to be able to take, as a same code base, looking for the same values, but change it based off of what function you're running, what API you're running, where you're at, and you can use settings along that lines. And when you set up the app configuration, and you use the feature manager, you basically tell, hey, I want to look for this label, and it will give you that label along with everything else. All right, let me see. Now, if you do use anybody use app configuration? No one's used app configuration. Okay. My pain point with app configuration, just so you know. You would think it would be really cool if I had an API, an app up and running, and I wanted to go through and I wanted to take this file signature verification feature flag and I just wanted to flip it, and then the app or API would automatically know, right? That'd be awesome. You can do that. However, you have to actually get a little old school, and it is built in the SDK. And you actually have to have a Sentinel here. It actually looks for a Sentinel feature. So if you make any changes to app configuration and you want it to replicate down to anything looking at it, you actually just have to pre-register and tell it, hey, I'm looking for this value Sentinel. And you just have to go in and manually change the value to it. Change it from a 0 to a 1. Doesn't matter what it is, just change it. So basically, app configuration from the feature manager and app configuration from the client side, it's looking for one value for changes to one value. And you set a cache value to it, so it'll only check every so often. I think the default is 30 seconds. You can set it for 5 minutes, 10 seconds, whatever the case is. But that's the only thing about app configuration that drives me crazy, because I don't know how many times people will go in and will enable a feature and people will be waiting for it. It's like, why is it not working? Oh, did you change your Sentinel value? No, I didn't do that. So hopefully at some point that we'll get that. Won't have to do that anymore. But for now, that's one thing. So if you use app configuration and you do want to refresh changes inside your application, please don't forget you have to register that Sentinel and do that, or else it just does not work. It doesn't matter what caching settings you set or anything like that. it simply will not work.
Well, shouldn't you just write an app to do that for the ones you want to change?
You should, yeah.
You write an app to change the value, and then
You could. If I told you how many little utility apps you already had for this blasted thing. So, in like this particular case, this is one of our other, this particular app configuration connected customer is, we took all their instruments used to be, and I think right now they're running about 150,000 instruments, used to be based off of, they used to just send their data up to a company called Digi that would store the data, and we would just basically pull down data from it. Connected Customer now allows us, has taken all those devices, put them on IoT. And so now we push software update, firmware updates to them, software updates on top of that. We get data from them. We can configure the devices from central location. A lot of great stuff. All this came basically on the heels of the pandemic, when they were started cranking out devices like crazy, and needed a little bit better way of controlling them and figuring out what was going on. So this guy has an absolute ton of configuration settings and feature flags in it because of all the stuff that it does. And it does everything based off of the different instrument types.
So what kind of data you can keep in the app config? Is that key value?
So it's basically key value. Through here, key value. You can put a content type if you want. Put anything in there. We've done everything from bits, strings. We put JSON blobs in there just to give us a little bit more control over things when we want to.
How big JSON blob?
What's that?
How big JSON blob?
I do not know what the limit is for that value. We haven't had any problems, but we haven't put anything massive in it, just simply because unless you are going to write an app to manage it, copy and paste, it gets a lot in there. And so we mostly use it for, the biggest JSON really that we've used it for is basically a pick list of some servers in their information, so that we can connect to the device and pick which server they need to based on geolocation. So it was 12 JSON objects with about 10 strings in each object is about what we had in it. So it wasn't anything massive.
So do you update this programmatically through pipelines?
Yes. So our pipelines will update. We have scripts, we have a script. This particular guy here has some crazy scripts because before we really understood labels, and like I told you, what we was talking about, when you don't understand something like labels, then you go through and you realize that you've got, for your feature manager, like Savannah, all these Savannah, it's one of our instrument types. So you have a whole group. Then you come in here, Sophia 2, other instrument types. Identical flags, we just have one for each instrument type. And that was before we understood the power of labels. And this is like one of our backlog things of going back and removing at some point so we can make life a little easier. So like right now we've got scripts that will go through and pull our list of instrument types and automatically create all these things and such. So, but yes, you can use pipelines and stuff to update these pieces.
PowerShell scripts.
Yep. PowerShell scripts. We've used Bicep. A lot of originally we didn't use Bicep in the last year and a half or so. We've migrating everything to Bicep to make our lives easier. And we do all that setup in Bicep as well. So, yeah.
So on the consumer side,
Mm-hmm.
do you have certain library that gets these values as soon as you update, or you mentioned something like signal?
Yes, so there is. Let's see, did I grab that? Put it down already. It says Farina. Okay. You have Farina down, so let's open Farina. There is NuGet packages for that.
NuGet.
Yep, and it is.
is that Microsoft provided
Yes.
libraries? Or?
Yes. Yeah, so Microsoft has, for the refresh and all that, there is a Microsoft Azure something or other.
So it just map into that configuration?
Yes.
And then it refreshes it, or?
So so for the features, there's a feature manager. And that feature manager, as long as you go through and refresh, use the app configuration basically provides you an iConfiguration refresher. And that's how it all works on the hoods. So as long as you go through and you take that, you will use that app configuration refresher, refresh it, then the feature manager basically does the legwork for you. And let's see. Setting the guy up is
Is that feature manager in the app service, or the feature manager is part of like running within your API?
So the feature manager is just the SDK running inside your API. It's this list that's talking to app configuration. I believe it's just using HTTP endpoints from the app configuration to manage all. Is what I believe it's doing.
So once the Sentinel hits, does it bounce your service, or is it the feature management refreshes it, and then you have to kind of, whenever you run an API call, you have to read?
You have to use a refresher. So you hit Sentinel, it puts it in a state, and so when you hit a refresher, that refresher is basically just looking for that one, if that one value is updated. And if it's updated, then it'll go through and pull everything else down.
Okay. Well, when you want to read everything else, then, like in your actual code, like you just inject feature management, and then you say check for this feature, and then do something. Or does it all happen at startup? Or is it dynamic at runtime?
So when you do, right, say that one more time.
So is it something that you, like, so for example, when you deal with like .NET configuration, a lot of it is applied at startup.
Correct.
Because you're reading all your static files, and usually they don't change, but they could.
Correct.
So is it that, where it injects into that kind of configuration mechanism, and then you have a dynamic configuration that updates?
So when you create your, when you connect your app configuration during your startup, that's when you set your, you enable a feature, like for the feature flags, you enable feature flags, and you set your cache expiration, things like that. They're part of the app configuration SDK is the concept of that iConfiguration refresher and a feature manager, iFeature manager interface. So use that iFeature manager that pulls whatever the values is it's sitting inside your API. The only additional benefit you get from that is that it will go through and update based off once you refresh your app configuration. Okay. I'm not answering your question anyway. I'm missing it. I feel like I'm missing it.
There's an idea there. There's a nugget there. I think what I'm getting is that there's a few different paths of what I would imagine. There's two paths. There is what happens at startup in your application. Like if you use feature flags to turn things on and off, like at startup. You want something that when you have a feature update happens, then your service bounces and all the new features are read, and you may turn things off or pull things in or change the configuration, right? Like your API instance starts back up.
Gotcha.
Or at runtime, whenever you have a new request, you kind of read the feature flags again every time you have a new request in your ASP.NET pipeline. And then from there, you can make a decision like, okay, what do I need to show and hide and do differently based on the flags?
Gotcha. All right. So this doesn't bounce the service. So what this does is when the API starts up, it pulls all the feature flags down. So when a request comes in, it goes through and maps. What this configuration, this refresher allows you to do is while that app is running to get an update on the feature flag. So that any code that you have or any functionality you have behind a feature, basically anytime you hit it, you would do a check on that feature flag. It's just cached locally unless it gets updated. So it's not bouncing the service to kind of refresh everything and all that. So we still have to kind of code for every time a request would come in, it would check that feature flag. And if that feature flag hasn't changed, then it's just cached and it carries on. So, okay.
So, how do you take care of the atomic chain? In the sense, like you have set up configuration that needs to go together.
Mhm.
Do you have a way that you can say, okay, if I change one key value pair and the rest of the key value pair is still not changed, how do you make sure that your API doesn't get newer value for one and the other one's just still looking at the old one?
So that is one benefit of that Sentinel value, because you can go through and change one configuration, one feature flag, and that's not going to get replicated down to the API until you change that Sentinel value. So if you've got 10 things you need to change, you can go through and change all 10 of them. And as long as your system is actually trying to pull the values from the configuration class or the feature manager and not storing that value somewhere, then you'd be fine. Because it would all come down once you hit the refresh, you use that refresher and tell it to refresh, it will get all that new data. So the next time it calls, it will all be synced and
Okay.
it'll be so that is one of the benefits of we've been actually running that. So now I've actually have one thing I like about Sentinel. So thank you, because I didn't like it at all. I did not like it. So now I have one thing I like that.
Scripts to change the features?
Was that?
Can you write a script to change the features?
Yes. So for the feature management, I'm pretty sure even the Azure CLI's got everything in it, so you can run it all from scripts, no problems. So, okay, so back to my train of thought. Okay, so that's app configuration, and so we use that inside of our system, and that got us up and running. From a scalability standpoint, that's how we used it. So we used APIs, we scaled them out in multiple regions so that we had the redundancy. We were able to shut them off, upgrade them as we needed to, or take them offline for whatever reason. And then we use everything else, was using Azure resources on the back end to make everything else work. That we'll dig into next. All right, so I said before, I'm going to say it again, I'll probably say it several more times. One of the things that people miss and that we ran into, nothing shows you problems in your workflow other than a ton of data, is backend resources. What we ended up having to do is we had to get very creative on how to handle a massive influx of data without stepping on Cosmos and things like that. So when it comes to creating APIs, one of the things, if you're creating especially massive data ingestion APIs, what we found worked really well was offloading it and creating this Azure puzzle. And what we ended up doing, let's come back over this guy here. Everybody here uses Azure Service Bus?
What's Azure Service Bus?
What's that? I thought we weren't doing all the intro stuff.
I have no idea. I'm just a guy, just sat here.
Just a guy, just
in
sitting
the
here.
front row, just trying to learn.
Just learning. Okay. Fine. No. Yes. So Azure Service Bus is a nice little feature to basically allow you to create queues of data. Right? It's just a quick, high-speed queue, really.
Messaging service.
Messaging service. Thank you. That was the word I was like. It's messaging something. So it's messaging service, and it is extremely fast. So what we ended up doing is, for our data, as I said, we had tons and tons of data coming in. Cosmos couldn't possibly handle it. So what we do is we actually, our APIs are making super fast, super efficient. Instead of, anytime we had data that either we had a ton of data coming through, there's a couple of cases for it, a ton of data coming through, or we had data, something that took a long time to run, right? HTTP timeouts for APIs typically default 2 minutes. You can play with that a little bit, but you're running more than 2 minutes on the API call and just have it pretty soon. So when we looked at tons of usage of API or APIs that ran for a long time, what we ended up doing is we used Azure Service Bus, and we, back here, and if you didn't know, you can group by type, and you have a ton of Azure resources. It actually comes really handy. So we come here to our Service Bus, and basically it's messages. And we'll take that data, dump in a message, we dump in a service bus. And we just let that guy spin up as much as we needed to. And what that allows us to do is makes our APIs be super fast. Because you get this data instead of, okay, now we're going to scrub the data, we're going to cool these, call this API to match this data up to this instrument. Then we got to hope that we're not 429 in Cosmos because it just loves being 429. All these kind of things. All we do is take the data, go, okay, thank you, throw it in a message bus. We got it, thank you, carry on. Super fast, and that's why that results API, we got up to where we're pulling in millions of records in an hour because it's really all it does. It takes data, dumps it in a message queue, and says thank you, and carries on. So it's super fast. The benefit, so when you have a queue, Service Bus lets you do two things, queues and topics. So queues are just a single instance of, it's just a queue, it's one message bus, right? So anybody can connect to it, anybody can send data to it, and then it's first in, first out. And as you pull that data, you can put a lock on it if you want to basically pull the data down and work on it. That way, if you fail it, it will kind of put it back in the queue, or you can accept it and pull it off the queue. That's what we're using here. The other is topics. And the great thing about topics is basically it's multiple certain message queue, message buses. So what you have is I send a message in to a topic, every subscription will get a copy of it. So if you have multiple processes in your system that need to take a certain piece of data or a certain queue off, something like that, and go through and process everything, topics are the way to go because everyone gets their own set of data. They can work out on its own pace, whether it's a instant process that's running, if it's a daily job or whatever the case is, that works really good. So what we did was, so this is kind of we have used this a lot and this works really great. This is kind of one of the really cool things. If you can use this, it'd be awesome. If you have a better way, I'd love to hear it. This is how we did it. So our system was take data in, either from an API, internal process, Azure function, like HTTP endpoint trigger. We take data, put it on the message queue. And then we would process that at a speed that we want to. Azure functions, everybody know what Azure functions are?
Actually, I'm not sure. I need a refresher. Functions.
We're going to do a round the world of Azure today. So Azure functions are Microsoft serverless APIs, right? Serverless web apps. So you can create an Azure function, you can have multiple endpoints. It's depending on how you have it configured in Azure, it's serverless, which means you can scale it up. You can do all kinds of great stuff with it, which means you can also hurt yourself with it. So you have to be careful with the scale up and all that. We had to deal with that. It's amazing when you have massive budgets and you could scale stuff up as much as you want to, how quickly you find that it doesn't really work and you really need to scale it down to just a handful of things running. But so one of the things Azure Function has is it has a bunch of different triggers, different types of functions you can create. A common one, especially for micro APIs, is an HTTP trigger, which basically spins up an endpoint. Right? An HTTP endpoint people can call into based any kind of web API. Another is a service bus trigger. And what this does is this guy fires anytime your queue has your service bus has messages in it. The great thing about it is it will scale out to how many concurrent calls you can. An Azure function, you can scale out to multiple instances of that Azure function, which works great for APIs and things. A service bus trigger, you could do that as well. However, the thing that you have to remember is that how it processes data is it processes messages as they come, and you start stepping on. They'll do concurrent, so you can do inside of your expanding out. One instance can run anywhere up to, I think, 16 or 32 messages at a time, and it'll basically thread it out. The problem you have with that is if you're dealing with backend resources like we reduce, so you can't scale that out too much, but you have flexibility to actually generate and churn those messages as much as possible at a high rate of speed. So what we would do for Cosmos, since our Cosmos database, especially for MyArena, has a lot of stuff that's working on the back end of processing, reviewing stuff, we don't want our ingestion to blow everything up. So we trick it down all the way down to a single message at a time. So it doesn't matter how much we have coming in, it's 10 10 records in a minute, thousands of records in a minute, doesn't really matter. We queue it up, one record at a time. We go through, we have this massive long pipeline that it has to go through, being the data's got to be matched up to instruments in our database. All the test results have to be verified. There is just, I think there's 18 or 19 steps it has to go through before the data is ready to be stored in Cosmos. And it requires a ton of API calls into different SQL databases and things like that. So we do that, and then we store it in our Cosmos, and we just do them one at a time. We can ramp it up to 2 or 3 at a time, but we've got the process running so fast that if we do that, then we start running Cosmos 429 issues. So what we do as kind of an overview, we take data in, we put it in a service bus, and then we can process that at a later time. Or if the data takes longer than 2 minutes or something like that, you're not worrying about that timeout. A cool little trick, and you can do with that, is you can also, if you pull that data in and you put it in a message bus, a lot of times it takes a little bit more time, but not too much. We'll actually combine it with Azure Table Storage, which if you have a storage account, you can add to table storage. And we'll take the ID, we'll put it in table storage, and we'll create another endpoint where people can kind of check on the status of things. Is it still queued? Is it being processed? Is it error off? Things like that. And so it's a great little full circle piece that you can do for that. We've used this in all kinds of scenarios. It works great if you've got a daily job that does like daily emails, sends out daily reports. Works great for it. We have a logic app that will kick off an endpoint and creates a bunch of messages for all the reports we have to create for the day. It runs at 1 o'clock in the morning, dumps them all in a message queue, and every single one of them have different query requirements, different things have to get built up, and we just go through, process them one at a time, kick them out, and not worry about resource problems or anything like that. So that's like one of the really cool things that we came out of this that has worked in a ton of scenarios, high-speed scenarios, delayed scenarios, things like that. Questions?
You know, since you handle the vast amount of data by separating it into regions.
Yes.
But the top level officers of the company probably want information about the totals. So you would extract information from each of the 5 things and put them together to generate reports for them, or what?
So for that particular scenario, we actually ended up with 2 different, it was receiving test results in 2 different modes. One, it was just, here's a JSON test result. The other was, here's the JSON test results, and we have some files we need to upload. And so that process could take, and basically what we ended up doing was like, great, we take a test result, we're gonna give you a SAS token to a blob storage. You have an hour, go for it, and then let us know when you're done, or in an hour we'll cut you off and we'll process it. All of our regions end up, the goal is to be zero sum, to never have data handling. So we put all the data in Cosmos, and there's another Azure function that we use a lot, which is a Cosmos trigger, that will actually trigger when Cosmos has changes and give you a page of data at a time. So all those regions have Cosmos triggers on them. So once that data has been completed and we mark the data as it's done, that trigger gets fired off. We go through and we take that data and we copy it to a main Cosmos. We then copy all the files over to main blob storage, which is more of a full blob storage, and then and that's how we handle it. So it ends up all in a central location. All of our regions it was a ton of work just to be able to offload everything. So, but yes, everybody needs it central, and most of our regions never have more than a couple records at a time in it because the stuff's being processed and sent up to the main location, with the exception of when we're under high volumes, then it might take a few hours for it to catch up. So we have for that one, management basically has has accepted a 12-hour window of any time a test result comes in, if a particular test result, they should be able to see it in their system within 12 hours. Most times within about a minute or 2, but it just kind of depends. So, and for that, we actually used Azure Durable Functions, which a lot of people actually, who has actually heard of an Azure Durable Function? Because I hardly ever, we came across that, and these are really cool. So Azure Durable Function is basically a orchestrated function that can have multiple steps to it.
It's a function with state. Is how I describe it. It's a function with state.
Yep.
Yeah. So it can be long running, months,
years. It doesn't matter. It's a really cool setup. And so basically, you can create if you start an instance of an Azure Durable Function and you have that state with it, you can set time triggers. So basically, I said we had an hour. So our durable function, anytime a record comes in, we create a durable function for that record. And within an hour, if we've created a container for it, it goes through, it makes sure that that the SAS token has expired, and if it hasn't, it clears it out. Then it updates the Cosmos record and just kicks it on down the line to be processed and sent up to the main repository. So every record we ingest in the region has an Azure Durable Function that, depending on the state and the workflow of it, will go through the pipeline to get where it needs to go. Which is really, it has some limitations we found. If you're using random thing, if you're using Azure Durable Functions, you have a time trigger to where you can have something fire off and give them amount of time. Less than a minute, it doesn't like. It's like, I feel like it's a 50-50 of it's actually going to fire or not. And it just doesn't fire, it just sits there. So you can kick it down the road. But the cool thing about Azure Durable Function is that you can get its current state, status, you can revive it, you can do a lot with it. It's got there's a nice little HTTP endpoint where you can access them, get more information about it. It's really cool. So if you've got long-running multi-step things, especially things that have to wait for other things to happen or things like that, durable functions are a really cool way to go. It's something to really kind of help scale out your backend and give you a lot of functionality.
Yeah, question. So you're talking a lot about the puzzle, right?
Yes.
How all these pieces fit together. How do you, let's say, like new team member on board, you're trying to visualize, like explain how does all this stuff fit together? What do you use to like see that and understand that?
Whiteboard. A very big whiteboard if you're not project. So the thing with that.
Could you repeat the question for online, Tony?
Oh yeah. That's sincere.
Yeah.
Right, so
they want to know.
Yep. So the question is if you're basically greenfield starting a new project and you are wanting to take all these pieces and basically architect out your system, how do you do it? And how do you go about it? So what we've done in the past, and my approach to it, and every project is different, and I'll tell people all the time, every project, it's just different. I typically start with data and work my way up from that. I at least try to get an idea of what my data looks like in general form and how much of it we're going to have. And then everything kind of drags off of that. And it's really just more of a feature process type development. What we'll do is we'll break down our processes of what we have to do. Because a lot of these pieces and such to make these things work originally, like if you talked to me 10 years ago, it would have been, okay, well, we just need to figure out how to make the API fast enough to do this 10-minute process in less than 2 minutes because somebody's sending us data and we have to figure it out. And by making the adjust to Azure, it's really just a familiarity with the puzzle pieces that you have to play with, the tools you have, and then looking at your process and taking one process at a time. For us now, there's the easy ones, right? We create our data for new projects. We spun one up about 6 months or so ago. Decided where our data was where it was going to be housed. Once we did that, we knew we had a couple APIs, different APIs that had to be stood up for various reasons. What the security of those APIs look like, and then we started looking at what our processes were going to be, what this data actually had to do, and that's typically. It's honestly some of the easier conversations to have with management and with the stakeholders because they typically know what they want to happen. It's the breakdown a lot of times I've had in meetings is they try to explain it to a developer in such a way that developers will understand what they're wanting to do. Where if with the Azure pieces and the way these things work together, it actually flows a lot better with more of a like mechanical workflow. And so you don't have to know the ins and outs of it. So we'll take the processes that someone will have, and okay, we know that this data is going to come in, and we've got some of our easy ones are scheduled ones, right? Right now, our workflow is if we're going to schedule something to run on a daily basis, you can create a time-based Azure function that will fire off at a given time. The reason I don't like those is because you have to bake into the code when the time is going to fire. You can't configure it. So I don't like those. I like something I can configure because it never fails. If I set it to run at 1 o'clock in the morning, for some reason I have to start running at 4 o'clock in the morning. And so then I got to have a code change to do that, and I don't want to do that. So what we do is, right, if it's a time-based thing, we know that we're going to set up a logic app that's going to be on timer, that's easy to go in and change. We can change it in code, we can change it however we need to, but easy if we had to on the fly. Such a logic app will call an HTTP trigger on an Azure function or an API endpoint, depending on how we're structuring it. It'll dump a message or messages up on a service bus to have this process as we need to. We know that we can manage at that point. We know we can control the flow of data. We can control the beat down on our resources, and we can get everything done. So we kind of break those up. And then from there, it's just one process at a time. And the building blocks just kind of keep building on. As with any type of solution for in a shop, we try to do two things. We try to reuse patterns where we can, so that anybody coming in doesn't have to learn 15,000 different patterns between different projects. But we always try to learn from project to project, or if we're trying to iterate through projects. So you'll look at the projects that we built for this system, like the labels for, like I was showing Connecting Customer. We didn't know about labels and didn't understand labels at the time. Now our projects, we use labels for things like that. At some point, we'll kind of go back and retrofit those things in. That's really the pieces to it. And while there's a ton of Azure resources out there when it comes to the development stack, I feel like there's really not an overwhelming amount. Half dozen to a dozen different, like, really core features that you can pretty much do everything you want to with. And there's some things that I said there's a ton of stuff that Azure will let you do. Some things just doesn't fit for us. Some things just don't work the way we want them to, so we want to do it our own way or a different pattern. And that's kind of the approach we take. Okay, so let's see here. I was going to show you something in Arena. Get out of the way. We've been talking about this for a minute, so let's just do this.
So is your APIs, everything is on Azure functions, or?
Our APIs are all web apps. They're all app services. Almost all of them.
App services?
Yes. If we're doing the whole thing I said, like we're just triggering things for to really not need jobs, sometimes we'll just stand up an HTTP endpoint because it's easy and we've got the code and we basically copy and paste it and we can go there. But
so API is taking messages and puts it in the queue.
Yes.
Then backend does.
Then there's an Azure function that sits there, listens to the queue has a service first trigger that takes that data and we'll go through and process it. And that's what we do every single time. Whether we put it now, talking about topics, most of the time we used to always use queues. Now we always use topics, even if it's just going to be a single subscriber listening to it. That way, down the road, you have somebody else who wants to listen to this data. All you have to do is add another subscription. It changes none of your existing code. It all works just fine. And you can spin up new code to go through and list those messages and work. Again, one of those learning things we didn't know about it, really at the beginning, but all of our stuff now, we use topics for.
So what type of security is being able for these endpoints?
So for our endpoints, we do a couple different things. We use, Azure, so my Verena, it's from a client side standpoint, we're using Azure B2C for our AD, and
Entra.
What's that?
Entra. It's been
Ooh.
renamed.
Has it? When did they rename that? Did I sleep? Okay.
It's now called Entra ID. Yeah, Azure AD is now Entra.
Is B2C still called Intra B2C, or is it?
No, it's like Entra. It's still it's B2C for external identities, I think. Same thing, man. Same thing.
I like B2C better. I'm going to stick with that for now. I did not know that.
Yeah.
All right.
Just a branding.
Every time you say it, he's going to correct you.
Probably.
He's just going to mutter it into the microphone.
Sounds like a drinking game waiting to
Probably
happen.
last 2 minutes.
Yeah.
The great thing I love about, you said intro?
Entra.
Intra. Okay. The thing I love about Intra for B2C, whatever else he said, is that it's really cheap to use up to 50,000 users or something like that. I mean, and you can basically put an AD back behind your application and not have to reinvent the wheel and worry about storing passwords and doing all that kind of stuff. So it's a great little thing. And I didn't realize I use it for all my like one-off projects and things like that because I'm never going to have more than 50,000 users. And if I do, I'm making money on it, so I don't care. But just for like little bitty apps, it's perfect. So we use that. So it means we're using MSAL, the MSAL library to bounce off that for authentication here. We use that a lot. Some of our stuff we use actually internal intros, and then we use token-based access for our external endpoints, for our RA that's ingesting stuff from our third parties and such like that. So we'll use token-based stuff on that. One of the things from a security standpoint that I always tell everybody is if you're ever going to create an API, secure it. I don't care if it's a free API that all it's doing is returning a list of states. And if somebody wants to get the list of states, secure. I don't care if it's a free token-based thing. Just take the extra time to be able to issue out those tokens and such, because as soon as you start creating APIs, at some point someone's going to take advantage of it, and it's very nice to be able to, with a push of a button, cut that access off. API is one of the great things about in .NET 8. It's got throttling built in, so you can throttle it there. Front door, we've used front door for throttling before as well. But those are typically how we do it. Mobile development, I use certificate-based for mobile development. Just to give me I use it for two reasons. One, I use it to give me just a warm fuzzy that it's not an open API, that my mobile app can actually has a client certificate that can push through and I can kill it at any time if I feel like it's not being used right. And then I use it for versioning. So each version of an app, we rev the client, and so we can actually do workflows and such based off of the certificate that we get.
So who are the callers of all these APIs? Is that coming from IoT devices? Or?
So this is the website. This is the Reno website. So we have our client-side website. Right now, out of the 150 or whatever thousand devices we have about 100,000 of them are used going through IoT that are sending our data through that. Then the rest is still coming through that Digi service that is coming through that. And then we have Results API, which is our third-party endpoint, which all of our QView, the mobile take-home tests and such, those are all coming from there. So a lot of people are using it, and it's coming through based on the usage of it.
So now I've got a question.
Yes.
You mentioned you're using .NET 8 to throttle, a feature of .NET 8 to throttle your functions when required. And I think you mentioned you had external APIs for developers. Is that? Yeah. So my question is, have you looked at using API management to help with any of that?
So
doing in code?
So API management, we've looked at it. We haven't used it yet.
Okay.
For most of our solutions, it seemed a little overkill.
Right.
And it was one of the few times with all the money that Quidel spends on Azure that they didn't want to spend the money on it.
Okay.
And that was kind of we looked at it, we were going to use it, and we're like, well, we looked at it late in the game. And so we were already doing pretty much everything that it was going to give us. And we didn't have any on-prem stuff to worry about, which is where it shines also, and kind of combining all that. And so we ended up, we didn't use it for that for cost reasons, the fact we already done most of it. So,
okay.
But it is really cool. And I don't know if if I had to start over, I feel like API management is for much larger scale APIs, like breadth-wise, than what typically we've dealt with in the past. Ours are, while it's high-speed stuff, it's typically pretty narrow. But it is out there in case y'all want to look at it. I don't know a ton about it other than we kind of demoed it and kind of looked into it and realized that for our particular projects, it didn't really work. But again, most of the stuff we were late in the game without.
So how are you going to manage a version of the APIs?
What's that?
Versioning of the APIs.
So versioning, so that's perfect. It's one of the other things I had on my list to make sure I talk about was versioning. The other thing, APIs, I'd always secure them and I always version them. Because if you don't version them, it's going to bite you and you're going to wish you had version. And I've never gone and not versioned an API and not regret it at some point and not have some kind of weird code I had to write it inside the API to manage where this data's come from. So we version everything. And we version everything to a point. So we don't rev it all the time. It has to be breaking changes for us, typically before we rev a whole other version of our API, because it is a little bit of work to do. It's very simple inside of Visual Studio. We have versions on this guy. One of the cool things about the controllers and such with the authentication. So this guy here has our token-based authentication for APIs for some internal use and such, and then the majority of this API is used by the client, the Verena client that I was just showing you. This allows us to basically, by taking this and extending, what we ended up doing was we mapped up all of our tokens-based controllers to a whole other set of controllers here, so we could basically offer all the same functionality that the endpoint and all that had, but add additional functionality to it. And this allowed us to basically allow our internal systems and such have more control and more access without even exposing those endpoints out to anybody else. Even though we authorize all of our endpoints, whether it's at the controller level or at the individual method level, we like to operate as secure as we can, which means if you don't need access to it, there's no reason you should even see it in the first place. And that's kind of how we've done this. So with this same code base, we basically have a /API that gives all the controllers, that gives us access to our to what the client such uses. Then we have a /token API / all the controllers. Same group of controllers, it's just extended more functionality, things like that. So it works out. That's a great way to extend that. And because RA is a version.
So is your version done on the query, on the URL?
So versioning, you can do versioning in .NET in 3 ways. And Swagger likes to really mess with you with it. So you can either actually send a header in your version and do it that way. You can put it in the URL as a query string, or you can put it in the path. And you can configure all 3 of those in .NET on which ones it will accept. Since Swagger likes to really monkey with that sometimes, but
in your case, which one you found easier?
So we went with putting it in the path, is what we did. The problem we actually run into that we have yet to resolve is that we have in our RA controller where we, one of the problems we had with the region is when we had multiple regions that we needed to maintain state for that caller. For somebody comes in and they give us a test result, if it's the case where I told you we had files, we had to tell them where the controller, the blob container was and give them that information. But they also needed to know which region to call back into to tell us they were done. So we ended up basically in a payload that we send back when you send us a test file or a test and say, hey, we want data. We send a payload of here's your SAS token, your blob container, and here's all this, but here's the endpoint you call to tell us you're done. We build it on the fly because it's in the regions, and we have yet to get the .NET APIs that figure out the version that basically it's got a great API that will just return the version and the path, the URL and such, but we can't ever get it to do it with it in the path. It always puts it in the query string. So we get support complaints of, well, I called V2, but in the past says /V1/ my endpoint query, question mark version 2.0. I don't understand. It's going to 2, just ignore it. It's something that we haven't figured out yet. So it's an outstanding headache bug that I have to fix at some point.
So is your endpoint also exposed to the internet? You worry about web application firewall or anything, or just internet services?
So we have one project that's firewalled off in the virtual network. Most of our stuff is open. We control the ones that don't need external access. We use Azure to limit the IP addresses that can hit it, and then we use managed. Another great thing in Azure to use for your resource, you use managed identities for it, so you can control, like if you're using Key Vault app configuration and such, instead of storing connection strings everywhere, you can use managed identity, and so it runs permissions that way. And that way you're not worried about expired connection strings or changing connection strings or this or that. You just use managed identity and give your Azure function access to a managed identity, and the same with Key Vault and give it the permissions that way. So, and then we'll just take our APIs, and it's a case-by-case basis. We looked at virtual networking off everything at one point, and to be honest, when you start getting to that gets beyond my scope a little bit, and I get frustrated with it, and I'm like, we're going to do it this way. I'm a developer, and I solved it using development stuff. But, all right, let's see.
How do you do your CI/CD?
Depends on the project. Let's see. So we use most of our projects. We use Azure DevOps for all of our projects. Most of them, we're actually storing our repos are in Azure DevOps. We had one of our projects. One of the managers had a conversation with somebody from the GitHub team, and they said, Azure DevOps is dead. No one's supporting it anymore. You need to move everything over to GitHub and GitHub Actions. I know one of the guys from the GitHub team, and he said, yes, they've minimized support of DevOps as far as from the repo standpoint. Yes, they're trying to get Actions up to the level of DevOps. However, they're nowhere near as close. But we do have a couple projects where we run GitHub and we use GitHub Actions, and it's horrendous. And I do not suggest it if you have any kind of complicated workflows, because it's just gnarly. I love DevOps, and we use all our pipelines for everything here. So we have we manage all of our builds. We do static code analysis. We run multiple. We typically run, depending on the project, it's another thing we've bounced on. We have run a couple different flows for our branching structure. Most of them have gone down to a developer domain. Sometimes we have a vNext in there. But typically, because we always run 4 environments for our stuff. We run a dev, a vNext, a test, and a production, where dev and vNext are off the develop branch.
You don't have separate staging and production. Like you can switch between, like you deploy into stage and then swap it, and then again deploy into stage and swap it. Right?
We don't do that. You can. No, what we end up doing is we roll it. It's a rolling deployment. So anything. So our typical scenario, we have dev and vNext run off of our develop branch. So any PRs that go into the develop branch automatically go to the dev, and then it's an approval process to get it to vNext. And then when it's ready for our testers, we'll PR from developing the main. That automatically goes in the test, and then so it has the latest and greatest, and then we go from there to main to make sure that all of our binaries go over, and it's not just the same code that's going over to production. It's all actual same binaries that are in test. Okay, it's one build for the main pipeline, and so those binaries are going over, so we don't have to worry about any kind of weirdness because we had that happen before that in the middle of sometime between testing and going to production, somebody was pulling down a latest package in something and it broke. So our test is the binaries that go over to production. But we do a rolling and we just do basically manual rolls through the DevOps CI/CD into each one of our environments. And the only exception to that is RA, the regions. When we shut them down, we do one at a time.
Is that the rolling feed? Is that the feature for Azure?
No, that's just how we end up doing it. So if you look at our releases, so we got our two are developed and our main. So this results APIs one stage. Find this guy here. All right, so develop here. So for all of our build pipelines, we build them out where we've got it's an automatic from dev, and then we just go through and approve them all for next, and then we've got the same for production off of our main. Our main will go through and so it's the same for main. Everything is queued up in main, and then we'll move it over. Everything's fresh because I was late because I was doing a release. We were doing a release today, and people got to talking. But
So this is actually a combination of logic apps and something that you're using.
so we run logic apps. We've built a couple of very complicated logic apps, but the logic app designer in Visual Studio has gotten much better over the last several years. Still not great. I haven't quite figured out why it can't be one-to-one, but typically what we end up doing is we will kind of build it inside of Azure and then take that and just kind of dump it back into ARM template and Visual Studio so we can keep it in code. But being that's the case, we don't build very complicated logic apps. Most of them are time-based triggers on, okay, at 1 o'clock, I need you, connect to Key Vault to get the permissions and connect to app configuration, get all this to build the URL, but then call this endpoint, and then you're done. And there's a few other things we use them for. But so we use logic apps, but we put them all in ARM templates so that we can deploy them. Our dev sometimes looks a little weird environment because a lot of times we'll build them in dev inside of Azure in the portal, and then we'll copy them and dump them over into Visual Studio and then parameterize them and all that kind of such. So, yeah, that's most of what we use. Let's see, what time we're done?
When everyone leaves.
When everyone leaves.
We've had a few people go.
Yeah.
But that's your guide, Tony.
Okay.
Yeah.
Yeah.
All right.
We can continue.
Yeah.
I can continue. Okay. And one other thing I want to talk about before we wrap it up, and I really should, if I'd had the right computer with my slide deck, it all looked prettier. But we're talking this through. Is data and your data sources. And one of the things that we have found that if you not use another resource that you really need to look into is Elastic search engine. If you've not looked at Elasticsearch, it is stupid fast. We use, when we built Myverena, when we built this guy, we looked at our original hope, because I remember we were actually at a build conference I was speaking at, and we talked to the Cosmos DB team, like, all right, we need big data, we got a ton of data. Is it going to hold up per query? Sure, no problem. at the time, we had a couple million records or something like that we did. It's not built for intense queries that like for a rapid fire from a website. It's just not built for that. It just, no matter how we index things, stuff like that, it was just too slow for what we wanted. It didn't give us performance. So what we do now is we have Elastic database. We have Elastic, and this guy, I said, we'll just start past 30 days. We've got a ton of results. So let's just say last 30 weeks, and then we can change it by storage date. And let's just make it complicated. Group it by facility. And this guy will run over the almost 100 million records we have in the database and return data in seconds. We have done crazy complicated aggregation queries in Elastic. So what we do now, the problem that everything has is purpose, right? Elastic is an in-memory cluster database. You can clone clusters and all that for redundancy and all that, but it still is an in-memory database. The powers that be at Quidel did not like that whatsoever. So what we use Cosmos as a source of truth. We get data, we process it, we scrub it, we do everything, it goes into Cosmos. Then we use a Cosmos trigger Azure function that anything that gets added or updated will go through, and then we push it up to Elastic. And then the website queries Elastic, with the exception of if you actually pull in a record detail, because we don't have everything in Elastic. There's some stuff we need to query off of and all that. And if you dig into an actual record and pull it up, it will see. It actually goes to Cosmos to grab all the details and such. This allows us to, and we actually have a system now, because over time, every once in a while you find things get a little out of sync. So we actually run a blue-green system to where we actually have 2 instances of Elastic, and we will, because it takes about 2 days to rebuild from scratch an Elastic database. So we'll have our current one running that's still updating, but we'll spin up a fresh one with fresh data, let it go through the Cosmos and build out a whole brand new one, and then we'll switch them. So the Cosmos change feed, if you're using the SQL style Cosmos, is great. It's basically an index. Every change has happened from 0.0 to the current. And you get a lease, which is basically an identifier for pointer in that index. You can, again, one of those weird things you have to be careful about paging, like spreading out Azure functions too much, because if you get a page of data, it moves that index up to the next page. If you have 3 different people calling it, it's jumping around pages and it kind of can give you problems. But so all you have to do to start from the beginning is you just have to delete your lease and start with a brand new lease, and then you can start at the very beginning. If you ever use Cosmos, if you come across Cosmos and you're doing the MongoDB, it does not have that in that form. You have to build it yourself. I've done it, but you basically have to they have a feed service, but they don't have the concept of the leases and all that, so you have to kind of build that out on your own, which is a fun little exercise to do. But we use that, and that seems to work. Another trick with Cosmos, I feel like I just need like a list of tricks. I think it's all this turned into, is a Cosmos change feed it's all those records that have changed that are still in Cosmos. So if you have a record in Cosmos that you've deleted, all of its changes go away. So for Elastic, for something like Elastic or any service that you want to know that, hey, something's being deleted, Cosmos has a time to live attribute that you can set. So where basically you take the record and say, okay, this guy will live for another 30 minutes and then it's being deleted. So that means it'll be in the change feed for another 30 minutes with that time to live marked. And so when you're processing, oh, it's time to live, it's got to be deleted. We can delete from Elastic and such. So it's a trick that we found out the hard way, that if you just delete it, it just removes all knowledge of it. So if you copied it over somewhere, you never know that something's been deleted from Cosmos. So it's one of those things you have to do.
Is it easy to get the versioning from the Cosmos?
The versioning?
You mentioned documents, it came to all the versions.
Well, so Cosmos is just document storage. So you can store, it has no form to it, right? Other than the properties you have indexed on it, it really doesn't matter what you have in there. So most of our, as of to date so far, we've been able to keep it all in one Cosmos. Our document structure has grown, and so our versioning is basically additive. And if we don't use a function piece anymore because we've added something else, then we don't put that in the document. Since we aren't doing a lot of querying off of Cosmos, we don't have very much indexed on it. Our key values for that record, which will never change, we index off of those, and that's pretty much all we index off of. If you indexed off of everything, one, it's pricier because it's just more to query and more to write and such like that. But it's a little bit more problematic if you start, well, I was using this feature, but then we weren't using this feature. Case in point, we originally our partition key changed that we started using. And so now if you look at our partition key that we use, instead of calling it partition key, which always call your partition key, we call it country code because our partition key was our country code, is what our country state code, how we're breaking down per state. We each do not remember the number if it's, there's some number, I feel like it's around a couple million or something like that you can only have in a partition. And we blew that off a state. And then it was like, well, what do we do now? So we refactored it all to where now our partition key is actually a date. We partition by day. But we couldn't change our partition key in our Cosmos. So now if you look it up, our records show country code, or country state code at the top with a date time in it. And everybody always asks about it. Well, we couldn't change it because Cosmos wouldn't let us change the actual, what we call the partition key. So we're kind of stuck with it. But that was one of the last things I wanted to make sure I covered, was to make sure you use your resources, your database resources as they're intended to be. And if you haven't used Elastic, you got to use it because it's amazing. And Elastic, if you're doing AI stuff, the OpenAI works great with Elastic. There's actually the latest version of Elastic has got a lot of AI stuff built into it, which has got some really cool stuff you can do. We're just now playing with, I don't have access to it or I can show you, but they've taken our data and we've run a 90-day window of data that we've got a chatbot that we're currently trying to get everything working just right on, but you can ask everything of what's the positivity rating in Texas over the last month, or what state, which county in the country has the highest positivity rating for flu, this or that. So we're currently working on building that out, but it works great natively with Elastic, so it's a really good spot. All right, any other questions? No? Well, I hope there was at least a couple of nuggets out of this. Again, appreciate y'all being tolerant of me being late and bringing the wrong computer with me, but I can sit here with a whiteboard and talk about this stuff all day. So,
yeah, thank you for attending.